Additional science, chemistry, topic 2, ionic compounds and analysis. Really quite a big topic with a lot of information all about ions, ionic compounds and their properties. We know that atoms normally have the same number of electrons and protons, making them uncharged overall. However, if an atom loses or gains electrons, it becomes charged and is then known as an ion. For example, sodium has atomic number 11, meaning it has 11 protons and 11 electrons. The electron arrangement is 2, 8, 1. If it were to lose the electron from its outer shell, we would call it a sodium ion, written Na+, and it would now have 2 full shells. Ions that are positively charged are known as cations. Another example is chlorine. It has the electron arrangement 2, 8, 7. If it were to gain an electron, to give it a full outer shell, it would become negatively charged, denoted as Cl-. Negatively charged atoms are called ions. Compounds are made when 2 or more elements are chemically joined together with a bond. Metals and non-metals react to form ionic compounds known as salts. For example, sodium, a metal, and chlorine, a non-metal, react to form sodium chloride. Sodium chloride is the salt. Note the ending "ide", which you can think of as meaning "and nothing else". So sodium chloride contains sodium, chlorine, and nothing else. If a compound has the ending "ate", it is telling you that it also contains oxygen. For example, sodium carbonate contains sodium, carbon, and oxygen. Let's look more closely at the reaction between sodium and chlorine. When they react, an electron is transferred from the outer shell of the sodium atom to the outer shell of the chlorine atom, giving both atoms a full outer shell, meaning they are now stable, which is of course how atoms like to be. Now in doing this, the sodium has become positively charged and the chlorine negatively charged. We know from physics that opposites attract, and this electrostatic attraction creates a strong ionic bond between the two atoms. Let's have a look at a second example, the reaction of magnesium with chlorine. If we look at the periodic table, we would find that magnesium has atomic number 12. So it would have an electron arrangement 2, 8, 2, telling us it has 2 electrons in its outer shell. Similarly, chlorine has an arrangement 2, 8, 7, meaning it has 1 space in its outer shell. So, in order for the magnesium to lose both its electrons and become stable, it must react with 2 chlorine atoms. 1 magnesium cation reacting with 2 chlorine anions produces the salt magnesium chloride, which has the formula MgCl2. In an exam, you may be given the formulae of different ions and asked to work out the formula of a particular compound. For example, what is the formula of calcium nitrate? Looking at the table, we can see that calcium ions have a positive 2 charge and nitrate ions have a negative 1 charge. So we would need 2 nitrate ions for every 1 calcium ion, giving the formula CaNO3 2. Now that they are joined, they create a neutral molecule, so there's no overall charge shown. Ionic compounds have a lattice structure. This means the ions are arranged in tightly packed regular formation. As discussed, they are held together by electrostatic forces or ionic bonds between oppositely charged ions. Because of these strong bonds, ionic compounds have a high melting point and boiling point, because lots of energy and therefore high temperatures are needed to allow the atoms to move apart. You can see the melting points are in the hundreds and thousands of degrees Celsius. Ionic compounds do not conduct electricity because the charged ions are not free to move in a solid state. However, if they're in a molten state or in solution, these ions can now move, which is what an electric current is. Solubility. A soluble substance is one that can dissolve in a particular liquid. If it can't dissolve, it's known as insoluble. You need to be able to determine if a particular salt is soluble or insoluble in water, and here are the set of rules to help you do that. If the salt begins with sodium, potassium or ammonium, then it is soluble. If it is a chloride, it is soluble apart from silver chloride and lead chloride. If the salt is a sulfate, then it is soluble except for lead, barium and calcium sulfates. If the salt is a carbonate or a hydroxide, then it is insoluble apart from the sodium, potassium and ammonium that we talked about in rule number 1. So you will be asked to identify whether a particular salt is soluble or insoluble, such as sodium hydroxide or lead chloride. So you need to remember all of these rules. Sodium from rule 1 tells us that this is soluble. Chlorides are too, but we need to remember that lead is the exception, so lead chloride is insoluble. Copper sulfate, sulfates are soluble, so copper sulfate is soluble. A precipitation reaction occurs when two soluble substances react to form an insoluble product, known as precipitate. A pure dry sample of the precipitate can be obtained by filtering the products to remove the solution part, then washing the precipitate with water and drying it either in the oven or between some filter paper. An example of a precipitation reaction would be to make lead carbonate. This is done by reacting sodium carbonate with lead nitrate, both soluble colourless solutions. Solid lead carbonate is formed as well as sodium nitrate. You would be expected to decide whether two solutions would produce a precipitate. In other words, you just need to work out if they're soluble or not. And you would also be expected to work out the name of the precipitate formed by essentially swapping the names of the reactants over. So sodium nitrate, lead carbonate. A particular precipitate you need to know is barium sulfate. This is a white solid that is given to X-ray patients and they eat or swallow it. It is opaque to X-rays. In other words, it does not let X-rays pass through them, so they show up on an X-ray image. It is toxic, however, because it's insoluble, it does not dissolve into the blood, so it does not cause any harm. Finally, you need to be able to, know some different ways of testing salts to find out which ions they contain and the results of those tests. So flame tests are used to find out what the metal is inside the salt. A wire loop is first cleaned by dipping it into acid and placing it in the flame of a Bunsen burner. Once it's clean, you then dip it in your solution and place it in the Bunsen flame again. If the flame turns yellow, then that tells us that the metal is sodium. Purple indicates potassium, orange and red calcium, and green is copper. To test if the salt contains chloride ions, then you need to add dilute nitric acid and silver nitrate, and a white precipitate would be formed. To see if the salt contains sulfite ions, you need to add hydrochloric acid and barium chloride, and again a white precipitate is formed. To test for carbonate ions, you need to add acid, collect the gas that's formed using a delivery tube and bubble it through some lime water, and it should turn cloudy. Scientists also use spectroscopy to identify different elements. This is a method which separates light into a colour spectrum using a prism. Every element produces different colour spectrum, and this was the method that was used to discover rubidium and cesium.